Okay, this is 2.2, and test scores. A student in an algebra course has test scores of 75, 82, 71, and 84. What score on the next test will raise the student's average to 80? So first of all, how do you do average? You have to add everything together and divide by how many you have. So they're wanting to know what they can get on their next score. So you have 75 plus 82 plus 71 plus 84 plus whatever your next score is. Now, how many is that? 1, 2, 3, 4, 5. So we're going to divide it by 5, and that they want to mean to have an average of 80. So we don't know what that fifth test score will be, but this is how you actually figure it out. So what score do I have to get on the next test so that my average is an 80? Well, this is how you do it. You have 4 tests so far. Your fifth test is you don't know, so you're dividing by 5, and then you solve from there. All right, so we multiply by 5 on both sides, and so now we have 75 plus 82 is 157, 257, 258, 342. Let me check to make sure that's right. So 312 is going to equal 400. 312 plus x, I should say, sorry. Now we subtract the 312, and we get x equals 88. So you have to get an 88% on the next test, or 88 points, whatever. All right, next question. Number 3, gross pay. Workers' take-home pay is $504. Okay, after deductions totaling 40%, so the deductions are 40%. Of the gross pay. We don't know the gross pay, so boom. And 40% of, meaning times, so 40% is 0.4, times your gross pay is going to be how much they took away from your check. And your check, again, your gross pay is X, minus the 40% of your check is equal to what's left, $504. All right, again, you don't know your gross pay. That's X. 40% of your gross pay is what they took away, minus. All right? So, again, what you don't know, give a letter and go from there. So now we just solve this. So this is 1x minus 0.4x is 0.6x. And now we divide by 0.6. And dividing by 0.6 is the same thing as 6/10. So 504 times 10 over 6. You could do it like that. So grab your calculator and do 504 divided by 0.6, and it's $840. So your gross pay, X, is $840. So think about it. If I took 840 and multiplied it by 40%, or 0.4, that's $336 that they took out. So is that right? 504 plus 336, that gives me the $840. Next. Intelligence quotient. There you go. If you take your mental age divided by your chronological age, and then you multiply that by 100, that gives you your IQ. So find the IQ of a 10-year-old child whose mental age is 15. Mental age is first. So part A, 15 divided by the actual age. So this person's mental age is, you know, they're older than what their actual age is. That's what they act like. Now you multiply it by 100. So you could take 15 divided by 10, no problem, on your calculator, and then multiply by 100. But you can see how easy this would be. 100 divided by 10 is going to give me 10. So 15 times 10 is 150. So this person has an IQ, this 10-year-old has an IQ of 150. All right, so part B. Find the mental age of a person. So mental age. So let's look at the formula here. So it's your mental age divided by your actual age times 100. That's going to equal your IQ. So there's your formula. You have to start writing things down with variables as you know how to do things, and you come up with your own formulas. So let's just fill in what we know. We don't know the mental age, X. The person's actually 15 years old. Going to multiply that by 100, and the IQ is 140. And now you can solve the problem. All right, so we can multiply both sides times 15 to get rid of the fraction, and then you're left with 100x equals whatever 140 times 15. That's 2100. And divide by 100. Okay. And x is equal to 21. All right, so their mental age is 21. Now think about it. Your mental age is bigger than your actual age if your IQ is above 100. That's what this is saying. Cost of installation. The cost of installing insulation in a particular 2-bedroom room is $2,400. Present monthly heating cost averaged $200. But the installation is expected to reduce heating costs by 10%. How many months will it take to recover the cost of the installation? Okay, so you got to figure out how much you're saving. So it's $200, and it's going to cut it by 10%. So we multiply by 10%, 0.1, and that tells us how much you're taking off, what 10% is. So 10% of 200 is 20. So you're going to take $20 off of the $200. They're going to be paying $180 a month. That's what they're expected. Now, how many months will it take to recover the cost of the installation? Well, if you're saving $20 each month, how many months is it going to take to reach $2,400? So 20 each month, so times X, however many months it is. What's it going to take to get to $2,400? So $20 each month to equal $2,400. So divide off 20. X equals 240 divided by 2 is 120 months. Okay, so 12 months in a year. So that's going to be 10 years. 10 years to pay off that insulation. So that's what you want to do when you first buy your home, is get that taken care of because you're going to live there a long time. All right, next. Savings account. An algebra student has won $500,000 in a lottery. He wishes to deposit it in savings accounts in 2 financial institutions. One account pays 4% simple interest, but deposits are insured only to $250,000. The second account pays 3.2% simple interest, and deposits are insured up to $500,000. Determine whether the money can be deposited so that it is fully insured and earns annual interest of $18,500. So first of all, let's just see if this is possible. Let's just invest the $500,000 in the 4% simple interest part, even though they're only insured up to $250,000. So just to get the normal problem going here, your interest is equal to PRT. So interest equals PERT. Easy way to remember this. So we want the interest to be $18,500. And so the principle is we'll just start with $500,000 to go from here. Times the rate, we'll say 4%. Don't forget that that's 0.04. Don't use 4. And over the time, all right? And he wants it in annual interest of $18,500. So annual meaning 1. So what is 500,000, use your calculator, times 0.04? And that gives me $20,000. So I am going to get $20,000 if I invest all of it in the 4% simple interest bank. All right, well, that's only insured to $250,000. He wants everything insured. All right, so it won't be possible to put it into the 4% one. If we put it into the 3.2% simple interest, here's what we get. So $500,000 times the 0.032, that would be 3.2 simple interest percent, so 500 times 0.032. That's only going to give you $16,000 each year. Okay, so let's use algebra here to figure out what we can do. Because he wants to divide up the $500,000. And if you play around with this on your calculator, you're probably going to see that you can get close. You're just not sure if it will actually work. And in the back of the book, it says it doesn't work. So let's show why it doesn't work. You have to be able to set this up. So let's say you're investing X amount of dollars in the first bank at at 40%, 4%, which is 0.04. All right, so 0.04 times the first bank. All right, now the rest, okay, so the rest is going to be 500,000 minus what you invested in the first bank. All right, and if we take that and multiply it by the 0.032 or 3.2%, and that is going to cover everything that we put into the bank account, okay? So if we add these two together, this is going to equal how much you're going to, how much you need to invest in each one at that interest rate. Okay, so in each one of these you have PERT. You have your principal, you have your rate, and the time is still 1 year. So you do have all of this. This is going to be your principal that you're, what you're investing in. This is your rate, and again, the time is 1 year. All right, so together, those both need to equal 18,500. So this is going to tell us whether or not it's possible. So let's figure out this left side. Again, we didn't know how much we're going to invest in one of them, and whatever we're investing in the other one, we take 500,000 minus it. So remember, what you don't know is always your variable. So let's figure this out. 0.032 times 500,000 is going to be 16,000 minus 0.032x. So I'm distributing the 0.032 here. And we still have the 0.04x there. So you have 0.04x and a minus 0.032x. All right, so 0.04 minus 0.032, that's going to be 0.008x plus 16,000. Is that going to equal the 18,500? All right, so if we subtract 16,000 from 18,500, that's going to be $2,500, right? So divide that by 0.008. So 2,500 divided by 0.008. So 312,500. So X has to be 312,500. That's what you have to invest in the bank that has 0.04% simple interest. And here, this is why it doesn't work, because he wants the total amount insured. Well, the first bank only insures up to 250,000. It's not that he can't get the 18,500. He can get that. It just won't be totally insured in case something happens. So he could still get what he wants, but it's not going to be fully insured. And he wants it to be fully insured. All right, let's go to the next problem. Number 11, movie attendance. 600 people attend the premiere of a motion picture. Okay, adult tickets are $9. So I'm just going to start writing as I'm reading so you can understand what I'm doing here. 9 times an adult. I don't know how many adults there are. And children were admitted for $6. So $6 per child. All right, now, so all the adults, I don't know how many there were, and all the children, I don't know how many there were, they equal 600 people. Now, it doesn't really say it like this in the story problem, but this is a very typical two-equation story problem. All right. $9 per adult, $6 per child. If the box office receipts total $4,800. So this is $4,800. How do we do this all the time? It doesn't make sense just to write these things down, but this story problem happens a lot. Let's make sure we get it. This one is talking about value or money. Many times it's money that we're talking about. This one here is talking about total numbers, okay? Not value. All right, very, very different, two different equations. The only way you can solve this type of an equation is if you have two equations. When you have two unknowns, you have to have two equations. All right, so we're going to solve the bottom one for A and say A equals 600 minus C. We're going to take that and substitute it in for that A. So 9 times 600 minus C plus 6C is equal to 4,800. And at this point, now you can do it, but you need to learn the beginning part of this. So So we distribute and solve. So 5,400 minus 9c plus 6c is equal to 4,800. So we're going to subtract 5,400 from the other side and put these two together. That's negative 3c. So 4,800 minus 5,400, that's equal negative 600. Divide off a negative c, and we get a positive 200. So there are 200 children. So how many adults are there? If there are 600 people there, 200 are children. That means 400 are adults. Tough problem, but this has happened in almost every math book you've had. You just probably weren't ever assigned it. All right. Next problem. Okay, so now we have the dirt problem. We had the PERT problem, principal equals rate times time, and that principal times rate times time is equal to interest. But now we have the dirt problem. Distance equals the rate times time. All right. So here we have two different vehicles going two different speeds, but they all left at the same spot, and the one caught up to the other one, meaning the distance that both have traveled has been the same. So if they both start here and the snowplow gets to there, the other car, he starts here and he goes faster than the snowplow but catches up to him. They go the same distance. When they catch up to each other, they go the same distance. That's what you got to get with this problem. Okay, so let's take a look at what we're doing here. The snowplow leaves at 6 a.m., traveling at a constant speed. Begins to clear a highway leading out of town, and then at 8 a.m., an automobile begins traveling the highway at a speed of 30 miles per hour and reaches the plow 30 minutes later. All right, so how long has the snowplow been going? So it's 8:30 in the morning now when the car reaches him. He started at 6 a.m. So he's been driving for 2.5 hours. So his time is 2.5 hours. So we'll say the snowplow, his time is 2.5 hours. All right. The distance of the car, okay, he's been going for 30 minutes. That's his time. All right, so that's your T. Now, what's the rate? The car is going 30 miles per hour. All right, so how far has he gone in 30 minutes? He's gone 15 miles. Okay, well, if he's gone 15 miles should be the distance here. So that's here, 15 miles per hour. Let's erase that and change that. 15. We don't know how long the snowplow, or the speed of the snowplow, that's your R. R is your rate, okay? But having known how far the car's gone, 30 miles per hour for 30 minutes, that means he's gone 15 miles. Well, they started the same place and now they're at the same spot, so that means that the distance of the snowplow is also 15 miles. So we don't know the rate of the snowplow. We do know the rate of the car, 30 miles per hour. Okay? So just to point something out here, if you look at that, you're saying, wait, 30 times 30 is not 15. Well, time in this respect is supposed to be in hours. Always remember that. So really, what you have on the bottom one here is 15 is equal to 30 miles per hour times 30 minutes would be 1/2 of an hour. All right, but we have enough information to figure this part out. So you probably could have read this, thought about it, and realized that this is what you should come up with. He's been driving for 2.5 hours. He's gone 15 miles. How do I solve for R? So R is going to be equal to 15 divided by 2.5. So get your calculator and take 15 divided by 2.5, and we get 6. So he's going 6 miles per hour. Remember, it's a rate. It's not his time. 6 miles per hour. And that's about right for snowplows. All right, next. A bullet is fired horizontally at a target, and the sound of its impact is heard 1.5 seconds later. if the speed of the bullet is 3,300 feet per second and the speed of sound is 1,100 feet per second, how far away is the target? Okay, relax here. So it's another distance problem. Distance equals rate times time. All right, so time. We know a certain time here. The time for speed of sound is going to be, if we divide by r, distance divided by r, that's the speed of sound. And the time of the actual bullet is going to be distance divided by the rate, okay? We don't know the distance, all right? So we do know the sound took 1.5 seconds. So the sound time plus the sound time on the bullet, that's supposed to be 1.5 seconds. If you add those two together, it's supposed to equal 1.5 seconds. They should be the same when you add them together. All right, so what do we have? For the sound, it's 1,100 feet per second. We don't know the distance. So let's just say the distance is x here. I'll just leave it as d. Just leave it as d. All over 1,100 feet per second. And the distance of the bullet, that's the same distance, so they don't need to be different variables. But the rate's different. It's 3,300 feet per second. Altogether, that's 1.5. All right, so now we got to get a common denominator, which the common denominator really is 3,300. So if we multiply everything by 3,300, okay, that removes all of the denominators. All right, so 3,300 divided by 1,100 is 3, so that's 3d. And these two reduce out, that's just d. And 1.5 times 3,300 is 4,950. So we have 4d equals 4,950 divided by 4. And you get 1,237.5 feet. All right, so if we were to actually put this together, we should get the same distances. So if you take 1,237.5 feet, that's your rate, or your distance, right? Distance here, if we divide by the rate, so the distance is 1237.5 divided by the rate of 1,100. Oops, 1,237.5 divided by 1,100. That's 1.125. And then you take, again, come over and look at the bullet actual distance divided by the rate. The distance, again, is the same, 1,237.5 divided by the rate of 3,300. That's 0.375. 0.375. And if you add those two together, you get the 1.5. All right? So that's just showing you how all this works to get those things. All right, let's go do another one. Lawn mowing rates. It takes a boy 90 minutes to mow the lawn. All right, this is applicable. 90 minutes to mow the lawn. That's the total. But his sister can mow it in 60 minutes. All right, how long would it take them to mow the lawn if they worked together using two lawnmowers? If we use unit rates and add these two together, then it's a different way of looking at this. So one lawn per 90 minutes plus one lawn per 60 minutes. And that really should be your total of one lawn over whatever it takes for both of them to do it. All right? So if we put all this together, we multiply by a common denominator of 180. Multiply by 180. All right? And figure out what all that is. And let's multiply by the x as well. 180x, I forgot the x is part of it. So up top, we're going to get 2x here. 60 goes into 83 times, that's 3x. The x is reduced and we get 180 on the right side. So 5x equals 180. Divide off the 5 is 36. So take 36 minutes for them to both to do it together. That's what the plus is here, together. His speed is 1 yard per 90 minutes, okay? So the rate at which they're doing it, all right? And the one lawn is kind of like your distance, because you're actually walking, pushing, and mowing the stuff, or maybe you're riding. So distance is your rate times time, and you can do one lawn, which is your distance, in 90 minutes. 90 minutes is your time. So the rate is 1 over 90. That's how fast the boy does it. So that's where this is coming from. And the girl is doing it 1 yard in 60 minutes. So that's what we call a unit rate. All right? Tough question. All right. That's it.